I was at a dinner party last night uh, trying to explain what we were reading for today's deep dive, and I realized there's just no way to say the name of the seventh planet without sounding like you're telling a joke.
Oh, 100%. It is the eternal punchline of the solar system.
Right, exactly. But after digging into this new data, I mean, I think the joke is actually on us for ignoring it for so long.
It really is. It's arguably the most interesting place in our neighborhood right now.
We aren't just looking at a fuzzy blue ball anymore.
No, not at all. The James Webb Space Telescope, JWST, has just delivered the first ever 3D map of its upper atmosphere.
And 3D map really isn't an exaggeration here. I was reading how they used the near-infrared spectrograph for this. They didn't just take a snapshot.
Right.
They stared at the planet for 15 hours straight.
Which is a massive deal because a full day there is only about 17 hours.
So they practically captured a full rotation.
Effectively, yeah. It allowed them to create a time-lapse movie rather than just a static image. They did this vertical tomography, mapping the atmosphere from the clouds all the way up to 5,000 kilometers.
Wow. It's like getting an MRI of a planet instead of just a selfie.
That's a great way to put it. You can actually see the depth.
And the first thing that jumped out to me from this map was the magnetosphere.
Hmm.
I knew the planet was tilted on its side, but the magnetic situation is wilder than I thought.
Wild is an understatement. On Earth, our magnetic field lines up reasonably well with our rotation.
Right, it makes intuitive sense.
But here, the magnetic field is tilted 60 degrees relative to the spin, and it's not even centered in the core.
It creates this wobbling, totally chaotic magnetosphere.
And that chaos is now visible in the auroras. JWST spotted two bright auroral bands with a very distinct dark gap right between them.
And that gap is the key.
Yeah. It suggests that as the planet spins, the magnetic field lines are actually switching topologies. Think of it like train tracks snapping and switching directions in real time.
It's just constantly rerouting.
Exactly. It's a phenomenon called magnetic reconnection. We see it on Jupiter, but here it's happening in this incredibly tilted, offset environment.
So it's this dynamic system where energy is being rerouted constantly. And, speaking of routing intelligence and energy where it's needed most, let's talk about our sponsor, Embersilk.
Yes. If you are looking to uncover where AI agents could make the most impact for your business or even your personal life, you really need to check them out.
Absolutely. Whether you need help with AI training, automation, integration, or software development.
Just go to embersilk.com for your AI needs.
So back to the ice giant. Here's the part of the study that really surprised me. We've got all this magnetic energy being dumped into the atmosphere, yet the planet is cooling down.
That is the big mystery. The data confirms the upper atmosphere has cooled to about 426 Kelvin.
Which is roughly 150 degrees Celsius cooler than what Voyager 2 observed back in the 1990s.
Right, which makes no sense intuitively because it's approaching its summer solstice.
It's getting more sunlight.
Exactly, so it should be heating up. But instead, it's doing the opposite. It totally challenges our current models of seasonal change.
But the even bigger puzzle is the decoupling they found.
Yes, the decoupling surprise.
This is the separation between the heat and the electricity.
Yeah.
Because in a standard model, you'd expect the hottest part of the atmosphere to be exactly where you find the most charged particles, the ions.
Correct. Usually the same energy source creates both. But on this planet, the temperature peaks way up at 3,000 to 4,000 kilometers altitude.
While the peak density of those ions is much lower, down around 1,000 kilometers.
They are totally out of sync. It implies that whatever is heating the upper atmosphere isn't necessarily what's ionizing it. We are missing a massive variable in how energy moves through these ice giants.
And for you listening wondering, why does the weather on a frozen ball 2 billion miles away matter to me? It's because this planet is basically a prototype, isn't it?
Precisely. The most common type of exoplanet we have found in the galaxy isn't a gas giant like Jupiter or a rocky world like Earth. It's the sub-Neptune, an ice giant.
So by solving these puzzles, the energy balance, the magnetic offsets, we're actually learning how to read the maps of thousands of alien worlds.
If we can understand this weird decoupling here, we can apply that physics across the galaxy. This study just proves JWST can do deep atmospheric science on distant planets right now.
Which is an incredibly exciting and optimistic prospect.
It is. It paves the way for a potential future orbiter mission to go there and see it up close.
We aren't just looking at a blue dot. We're unlocking the physics of the universe.
It's a very bright future for planetary science, honestly.
Definitely. So here's a thought to leave you with. If this magnetic switching and decoupling is happening on the most common type of planet in the galaxy, Maybe these chaotic environments are actually the standard for the universe.
Oh, that's an interesting angle.
Right. Maybe Earth's polite magnetic field is the weird one, and we have a lot more to learn about how dynamic planets really are.
That is a fascinating perspective. It puts us in our place in the best possible way.
If you enjoyed this podcast, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.